This video will continue our discussion of section 4.6 with another example. So this is another equation we can solve with variation of parameters. The reason I picked this one to go over is we have to make sure that these equations are in the correct forms. This form required, if we look back at that first video, the deriving of it, it has to be in standard form. So standard form means that the leading derivative is has a coefficient of 1. So if I divide everything by x squared, I'm going to get this equation, which is very important because that means I'm having to divide that secant over x squared. All right, so if I wouldn't have done that, my f of x would have been wrong. In this problem, they went ahead and gave us the solutions to the homogeneous case. So that is going to be c1 times cosine ln of x plus c2 sine ln of x. All right, so we have that solution. That's where we get our y1 and y2. So this is y1 if you want to label, y2. So the Wronskian will be, okay, our solutions. So the first one is cosine of ln of x. And then the derivative of this, cosine is going to be a negative sign, and then derivative of ln of x is a 1 over x. So I get negative 1 over x sine ln of x. For y2, I have sine of ln of x. This is the same, except for I don't get the negative because that doesn't produce a negative. All right, if I work this out and multiply, you guys can see I'll get 1 over x cosine squared ln of x plus, because the minus negative, 1 over x sine squared. So notice that we have our Pythagorean identity. As long as the argument ln of x is the same in both, we can use our identity. So this is 1 over x. All right, I'm going to shrink this up because I'm going to fit all three across right here. So now W1 will be the first column. We'll switch to our 0 and our function. So I get 1 over x squared secant ln of x. And then I keep the second row the same. Sine of ln of x, 1 over x cosine ln of x. All right, doing that determinant, the first multiplication is 0, and then I'm going to get a negative because I'm minusing, and I get 1 over x squared is still there, and then secant is just 1 over cosine, so sine over cosine gets me a tangent, and since they both have ln of x, I can do that. So there's W1. All right, all we need now is W2. W2, we keep our first column. And then the second column turns to 0, and then just be careful you're writing everything right. I think when I was working this out, I messed up right here, and it crashed my whole problem, just because I wrote something down wrong. All right, so that's what we have there. The minus multiplication will be 0, so that's gone. And cosine and a secant, secant's 1 over cosine, so I'm going to get a nice, pretty x squared here. Okay, to find now I have all three. Find our solutions. U1 prime is going to be W1 over W. So W1 is negative 1 over x squared, tangent of ln of x, all over 1 over x. You can think about this a couple ways. You could think about flipping and multiplying, or you could think about there's two of them on top, one on the bottom. I'm going to cancel one of them out. All right, so there's my U1 prime. So U1 then is going to be the integral of that. So I'm going to go ahead and put the negative out front. Thankfully, this just requires a couple u subs. My first u sub is a pretty obvious one. If I do u equals ln of x, du is 1 over x. So this just changes to a negative tan u du. And I made a mistake that I get on to students about all the time. We need a dx. All right. So now this might still not be obvious. This is just sine over cosine. Sine u over cosine u. And it's just another u sub. This is going to get me if I do a u sub of cosine, u equals cosine, I get negative sine. Well, there's a negative I could just put on top there. So I could just erase this negative and put it right here. And you can see that the u sub would cover that, and I'd get 1 over u, which is ln of, and it's going to be that cosine, but then we're going to replace u with ln of x. There's u1. All right, u2 prime is w2 over w1, which is 1 over x squared over 1 over x, which is just 1 over x. So u2 then is going to just be an ln of x. That's the integral of 1 over x. So our particular solution then is going to be ln times cosine of ln of x times cosine, that was y1, plus ln of x times sine of x. Right? Then our overall solution is going to be C1 cosine ln of x plus C2 sine ln of x plus this whole line here. Cool. And there's our overall solution. Be very careful, even like recording these videos. I make these little mistakes, and this solution's correct. I make sure it's right. I do my problems beforehand. Try to avoid any mistakes in the videos, which can be difficult. Um, just know that these being so dense, it's very easy to forget a negative somewhere, or forget a 1 over x, or forget I made a mistake. I put a square right there, and it messed up my whole problem. I don't know why I put a square, but I did. So you just have to be careful, go slow. Um, all right.